Okay, this figure illustrates the time course of signal transduction. The time course of signal transduction is shown here. So you can see that the process begins with binding of a first messenger. Okay, this is the first thing. Okay, of course, you start with that. So we have binding of a first messenger, which leads to activation of ion channels, of course. Okay, activation of ion channels, and you can see the short duration here, bind to the first messenger, then activation of ion channels or enzymatic formulation of second messenger, of course. This in turn can cause activation of third and fourth messengers, which are often phosphoproteins, of course. So here we have the activation of third and fourth messengers. If genes are subsequently activated, we have more than one type of gene expression. So this leads to synthesis of new proteins, of course, because that's why we need genes. Genes are translated to proteins. So what are these proteins? Proteins in general, general speaking, we will talk about some details in a minute. But if genes are activated, this can lead to, as we said before, to synthesis of new proteins that would alter, in general, the function of the neurons. So once initiated, the functional change due to protein activation or new protein synthesis can last for at least many days and possibly much longer, according to the kind of change, I would say. So we have activation of. So the ultimate effects of signal transduction cascades triggered by chemical neurotransmission are not only delayed but also long-lasting by this way, when we are talking about gene activation. So we have binding to first messenger, activation of ion channels, enzymatic formulation of second messengers, activation of third and fourth messenger, activation of early genes, then activation of late genes, and that would lead to long-term effects of late gene production.